Hey guys, today we are going to be learning about the quadratic formula. Before we dive into that though, let's just review what does it mean to solve a quadratic equation. So we're going to be finding where the function crosses the x-axis or where it equals 0. So here is a picture of a quadratic graph. As you notice, it intersects with the x-axis at 2 points. Those points or locations can be called zeros, solutions, x-intercepts, or roots. So we have already learned two methods of how to solve a quadratic equation. We have been factoring and setting equal to 0, and we've also been graphing, just like in the last slide, where we see where it actually crosses the x-axis. Our new method is going to be the quadratic formula. So what is the quadratic formula, you may ask? It is this big equation. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over divided by 2 times a. So this is a large formula. However, you are not required to memorize it. This will be given to you on reference sheets. And you can always refer back to it in your notes. So you may be asking, why do I need to use this huge equation? Well, it is a formula that can be used to solve any quadratic equation, even when factoring is impossible. So sometimes when we are looking at trinomials, there are sometimes we cannot figure out what multiplies to the constant and adds to that middle term. And in that case, we're going to use the quadratic formula because just because we can't factor it does not actually mean there are no solutions. So there are a lot of variables in this equation. There's an a, a b, and a c. And as you see, I did color code them. So these variables actually tie in together with the coefficients that are in a quadratic equation that's in standard form. So remember, standard form starts with your largest exponent all the way down to no exponents or no variables. Here we have y equals ax squared plus bx plus c. So basically it goes 1, 2, 3, a, b, c. So if we look at the equation y equals 2x squared plus 3x plus 6, we notice that the a is our first coefficient, 2, our b is our second coefficient, 3, and our c is our constant, which is 6. So a, b, c, 2, 3, 6. All right, now I'm going to show you how we can actually solve this.
Okay, so we're given a new equation here. 2x squared plus 5x minus 3 equals 0. So our first step in solving this quadratic equation is to make sure that the equation is in standard form, which as we can see it is, and we are going to identify the a, the b, and the c. Now remember, the a, the b, and the c go in order of the trinomial. So our first coefficient, 2, is going to be our a. Our second coefficient, 5, is going to be the b. And our last constant, negative 3, is going to be c. Step 2, plug in the values a, b, and c into the formula. Again, the formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So we're first going to start off by rewriting x equals negative. Then we are going to insert the 5 because that is our b. We are then going to write plus or minus and then draw a nice large square root sign. In that square root sign, again, we are going to put a b, which is 5. We are going to put the exponent 2 and minus 4 because that will never change in the formula. Now we will multiply times 2 because that is our a, and we will multiply times negative 3 because that is our c. We are then going to divide the entire thing by 2 and multiply that by our a, which is 2 as well. Step 3, evaluate and simplify. We're going to start off by evaluating everything under the square root sign. So we're going to rewrite x equals -5 plus or minus the square root. Now, 5 squared, 5 times 5 is 25. -4 times 2 is -8. -8 times -3 is a positive 24. We're going to divide all of that by 2 times 2, which is 4. Now we're going to take this a step farther, and we're going to add 25 and 24. So that leaves me with x equals -5 plus or minus the square root, again, 25 plus 24 is 49. And we're going to still divide that by 4. Let's take this one step further and simplify the square root of 49. X equals -5 plus minus 7, because that's the square root of 49, and still, again, keeping our division sign, over 4. If we're looking at this and we say -5 plus or minus 7 over 4 looks like a weird answer, you would be correct. So that is why step number 4 says we're going to state our solutions. When stating our solutions, we want to break up this plus minus sign into 2 different solutions. So I'm first going to write x equals -5 plus 7 over 4. Now this is a little easier to solve because -5 plus 7 is 2 over 4. And we should all know that I can simply divide both of these by 2 and simplify my answer to get x equals 1 over 2. So that's one solution. Now remember, this was a plus and a minus sign. So here I did the plus. Down here, I will now do x equals -5 minus 7 all over 4. So -5 minus 7 is -12 over 4. -12 divided by 4 is -3. So now we have our 2 solutions, a positive 1/2 and a -3.
Okay, so I know that was a lot. I'm going to go through one more example with you. Here we have 3x squared plus 10x plus 3 equals 0. So again, the first step is to make sure our equation is in standard form and to identify our a, b, and c. Our a, in this case, is 3. Our b is 10. And our c is 3. Our second step is we are going to now plug these values into the formula. So here I already have it kind of set up. X equals -b, so I'm going to put 10, plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is 3, and c, which is also 3. I'm then going to divide all of that by 2 and multiply that by a, which is 3. Our step 3 is we are going to evaluate and simplify. So I'm going to leave this -10 and this plus or minus sign. I'm going to rewrite the square root, but this time I'm going to actually do 10 squared, which is 100. And -4 times 3 is -12, and -12 times 3 is -36. I'm going to divide all of that by 2 times 3, which is 6. I'm going to come over here, and I'm going to simplify this even more. So I'm going to get -10 plus or minus the square root. 100 minus 36 is 64, all over 6. Again, I'm going to simplify it a little bit further by finding the square root of 64, which is 8. So we have -10 plus or minus the square root of 64 is 8, all over 6. So now over here, I'm going to separate my two x's. Here I'm going to put negative 10 plus 8 over 6. And over here, I'm going to put negative 10 minus 8 over 6. This is going to become negative 2 over 6, which reduces, I'm going to put over here as my solution, negative 1 over 3. So that's one solution. My second solution, negative 10 minus 8 is negative 18 over 6. And negative 18 divided by 6 is negative 3. So there you go. That is two examples of how we can use the quadratic formula. I hope this video was helpful, and I hope you guys get the best out of this.